Okay, so Android has some really cool kind of shared preferences that allow us to write a key value pair very quickly and easily. And I've definitely seen people cram a lot into shared preferences before. But in order to really be a developer of content for a mobile device, you really need to know how to read and write files manually, not only for your code, but for troubleshooting and understanding how that process works. So let's actually take a Notepad example and save the entire contents to disk and read the entire contents to disk like a real software developer would. And we're going to use try catch finally to actually help us do this as easily as possible, regardless of what might happen in between. I'll show you. So in our persistence activity, I have two methods. I have get text file and save text file. We're going to start with just save text file. Now, before we actually jump into that, I do want you to notice that I have a name of my file. It's just my file. And what I'm going to do is I'm going to actually take whatever this string is and write it to disk. So if we open this up a little more so you can see it, you're going to see a lot of code blocks. The first thing that you need to do if you're actually going to save something is you have to be able to get a reference to what's going to be streamed to disk. For that, we have this thing called file output stream. And I'm starting with it being just null. I know I'm going to have a reference to it, but I'm just starting kind of with a blank one. What I'm going to try to do, and the reason why we're trying to do this is because, again, these are not errors that are a part of our code. There's a ton of different reasons why you couldn't open a file. There could be the file doesn't exist. There could be incorrect access to disk. Someone could be trying to do it at the same time. It could be locked. So we're going to use most of our reading and writing file operations inside of a try and catch block. It's really simple. There's a method called open file output that gives you a file output stream object to the data file that you're actually specifying. Now, if you want to actually try to get something very specific in the Android operating system, there's also file objects like this. And this file class you can actually reference by specifying very particular paths or resource streams. I'll let that be an exercise for you, or you can ask on the forums. For here, we're just going to go with the simplest example, which is just opening just one file by open file output. So, open file output, and then it's this simple. We use the method write to take our content, and we actually have to convert it to the actual bytes. We're not going to write a string. We're going to just write the raw data to file, and that's pretty much it. The rest of this code is for what happens if something goes wrong. The deal is that you could be opening a file and you could have an issue, in which case we might have an I/O error. Or maybe it won't be found on disk. No matter what happens, this is an actual stream. It's not the way that we think of memory usually working. We need to make sure that if we're going to open up this stream and start chucking data into it, that when we're done with it, we close up and clean up after ourselves. Otherwise, we might leak memory, we might make things corrupt. So we just want to be good developers and clean up after ourselves. That's why the finally block is awesome. No matter what happens, if it's successful, if there's an error, we just say, okay, just make sure that this thing still isn't null, and then close the stream. This is guaranteed to run because of our finally block. And this allows us to clean up after ourselves without having to worry too much. Okay, so that makes sense for saving a text file. But what about reading it? Well, if you look here at our get text file, which is going to read it, it's going to return it as a string. It's very similar, but a little more complex. For one thing, I'm getting something called an input stream, very close to the output stream. I'm also starting with a string of what I actually want to return at the end of all this, and just kind of setting that stuff up. That way everybody can see it and reference it in scope. Here we don't actually need a particular mode for writing. We're just going to open the file and put the same data file. But here's where things get different. First thing that we have to do is we actually have to get a size of how much we're actually going to be able to take in. And so we're going to take a size for what is actually available on the input stream. We're going to create a buffer, a very small little section of bytes that are the size available of the input stream. And that's what we're going to use to actually read in this data. Here you see that we're reading in the data from that file and putting it into that buffer. So that means that that buffer is slowly going to get filled with all the data from the disk, or at least from this file on that disk. Here we're closing up our input stream and finally converting that buffer into a string. The reason why I have to actually specify UTF-8 here is because, again, this is just raw bytes. Converting raw bytes to a string requires us to know how to do that. There are many different encodings. So this is just specifying the encoding so that we can actually go from bytes to what we originally had as a string. So even though you saw me close this here, same type of logic still applies. I'm kind of just doing this so I know what's happening in what order. But at any point in time, something could go wrong. Which is why, again, with our finally block, we have our file input stream close if it's not actually null. And this is going to protect us from any particular issue of not being able to find the file, errors, corruption, etc. Finally, we return the file data. Okay, so now that you're saving and you're reading and writing to disk at breakneck speed, where do we actually save and restore this file when we're dealing with Android's lifecycle? Well, actually, I don't really want you to see that. I want you to imagine in your head what the answer is. Okay, that's enough time. What I want you to look at here is that I've chosen on pause and on resume to read and write whatever is in the view. Here on pause, I'm saving the text file the minute that our activity is paused and taking all that text that is actually on the screen from our edit text view. And on resume, I'm immediately setting it to be what is actually from the get text file. Now, the reason why I'm doing that is because I'm trying to make a live notepad experience here. I want that data to persist immediately and obviously, no matter if you get a call from somebody or whether or not you quit the app for a couple days. So let's see if it actually works. Here we have it. As you can see before, this is the third time I've run this particular project. I'm just going to write something in here. Dear Diary, I love making Android apps. Note to self, make more of them. Sincerely, me. Okay, well, what happens if I leave? Come back. What do you know? That persistence is still there. This could actually be completely closed down. We could shut down our phone. We could close this and then come back to it a while later, and it will still be there because we're actually persisting that data to disk.